So today we are diving into the concept of composite function and what is composite function. So this is a very interesting logic in mathematics. So right I'm writing composite function over here. So this is not a rocket science, and this is a very easy concept, and I am going to give you in-depth detail about composite function. And if you don't know about composite function, so you can check out my first video about function, and I have explained in detail about the functions in my first video, and I'm going to provide the link here. So composite function is a function, as you can guess from the name, it is the composition of functions. It may be two functions, it may be three function, it may be four function, it may be five, six, and so on. And there is there is no restriction on how many functions there will be in composite function. It may be, as I told you, it may be two, it may be three, it may be four, and it may go on, and it may be five, six, and so on. So composite function is basically the composition of functions. It is basically the composition of more than one functions. Okay, so what does it mean? Why we use composite function? Why do we need a composite function? So before telling you that why we need composite function, let me tell you an example which could help you to imagine the composite function in real world. So imagine I have a car over here. So I'm not good at trying car, but I will try. So I have this car over here, and this is the frame of the car. Okay, this is the car over here. So I'm going to perform two functions on this car. The first one, I'm going to build the frame of this car, and the second, I'm going to color this car. Okay, so basically I'm performing two different functions. So the first one, as I told you, that I am just building frame. This is the first function, and the second function is just to color the car. So I can't color the car before making the frame of this car. So this is the basic idea in composite function, that you have to do the function, the composite function processing in steps. Okay, you can't just randomly go to the last function. You have to do the first functions. Okay, then you will definitely get to the last function. So this is the core idea about composite function. I have two different functions. So the first one over here is f of x equals x plus 3. So what it does, okay, what this function does. So this function adds 3 to whatever I give it. For example, if I give it 2, then it's going to give me 5. If I give it 3, it's going to give me 6. So that's what it does. And I have another function over here that multiplies the value, the value I give it. It's going to multiply that value with the 2. It's it's just doubles the value. So I have these two functions. So I can combine these two functions, and the time I combine these two functions, there's gonna become the composite function. So how can I combine the composite function? So I can combine the composite function. This is a basic notation in mathematics we use very often in mathematics. We can denote this. I'm going to give you the denotation, the basic denotation of how to denote a composite function. So this is the basic denotation of gf of x. You can also denote another way. I'm going to give you the full intuition. Okay, so don't worry. So as you can see here, so f of x. Okay, so this function over here, this function over here, x plus 3, it's in the domain of g function. Okay, so this value comes here. Okay, so this is in the domain of g function. Okay, if I want to reach the x value, the exact x value, so first I have to do function on f of x, then I have to do function on I have whatever answer comes, I am going to put then that answer in the g of x function. Then this is a composite function basically. So this is not a big deal. So this is the first way. Okay, and this you can see that the f of x in the domain of g. There's another way where I can put the g of x in the domain of f, and this is also where it depends on you that the function goes in which direction. Okay, it only depends on you that the function goes in which direction. So I can also put like this f of g of x. So as you can see right here, the g of x is now in the domain of f of x. So it means that this 2x goes over here. I'm going whatever values whatever values come from the answer of g of x, I'm going to put those values in this x domain. So this is basically the intuition behind the composite functions, and I hope that you would have understand better. Okay, this is the idea behind composite function, and I'm telling you again that the composite function is basically the composition of functions. It is the combination of more than one function. So now I'm going to solve a composite function in front of you, and you will be able to understand it in more depth. So I have two functions over here. So the first one is f of x equals 2x minus 1. So this is the first function, and g of x equals g of x equals 3x plus 5. Okay, so these are the two functions. So the first one it asks me to do is g f of 4. It means that whatever values comes from g f of 4, put that value in the domain of g. So there are plenty of ways to do this, but I'm going to use the easy way, and then I'm going to use the other ways as well. And because I want to give you the full intuition behind the composite function, not just easy tricks. So the first one, I have to solve these two I have to solve these two function. I have to make a composite function. Okay, not put the values first. I will solve the composite function, and then and that composite function i'm gonna put this for value over here. So how to do this? As you can see that f of x, okay, f of x is in the domain of g of x. So okay, f of x is in the domain of g of x. So it becomes g f of x. So this is the f of x function, which is 2x minus 1. It is in the domain of g of x. So I'm going to put this 2x minus 1 in here in the domain of g of x. So it would be 2x minus 1 plus 5, and I have to put the under root. Okay, so now I'm going to solve more. So this would be the complete function. 3 times 2 is 6, and 3 times 1 is minus 3, and then plus 5, and this is in the under root, don't forget. Okay, so now it would be g f of x equals 6x plus minus 3 plus 5 equals plus 2. So I again forgot the under root, but you should not forget this. Okay, so now I have this composite function. Okay, so I have built a composite function g of f of x. In this composite function, now put x equals 4, because this asks me to find g of f of 4. It means that put 4 in the domain of this composite function. So I have to put 4 in here in the domain. Okay, so it would be g f 4, I have a little space over here, and I'm sorry for this. So 6 times 4 is 24 plus 2, and 24 plus 2 is basically 26. So this is the solution for the composite function. This is the solution for the composite function. This is the 26. Oh, so I again forgot the under root. So 26 under root is the final answer of this composite function whenever I put x equals 4. So this is the final answer. So I told you that I'm going to use another method. And what is the another method? So let me erase this from here. Let me erase this. Okay, so I have a little space over here. Let me erase this, and I hope that you have understand how to solve the composite function, how to build a composite function. So there's another way. So another way is like this. The question asks me to find to find g f of 4. So first put 4 in the f of x function. So if 4, it becomes 2 times 4 becomes 8 minus 1. So this is 8 minus 1 is equal to 7 is equal to 7. So now I have this answer from the f of x function, and I have to put this f of 7 in the domain of g of x function. So let's come over here. So g of f of x is now f of 4 is now 7. So I'm going to put 7 in the domain of g of x. So this is 3 times 7 plus 5. So 3 times 7 is 21, and plus 5. So the g of 7 equals under root 26. So you can see that the both answers are same. You can solve it, in any way you want, but I have shown you the 2 ways because you are going to need these 2 ways. So this was for today. We will meet in another video.